Hello, I'm here back to do the second part of this paper, which is question 21 to 40, which is the chemistry part of this paper. Meaning it's the part 2 of the paper, science paper for 2019, 29th October, chemistry physics. So the second part is going to be the chemistry part of it. So allow me to go to the chemistry part of this paper and close it up, finish it off. We straight away go to question 21, which is this one here. So which statement or statements of matter, which states of matter exists at freezing point of a substance? Which states of matter exists at the freezing point of a substance? The answer is B, solid and liquid. If it's freezing, then it's turning from liquid to solid. So part of it, the liquid will be turning to solid. It won't turn at once to solid throughout itself. Therefore, to be partly solid and finally to be completely solid. Our answer is B. Question 22. A measuring cylinder is used to measure the volume of a liquid. What is the volume of a liquid contained in the cylinder? You have to look at the lower meniscus, this part here, not this end part which is raised up, okay, caused by adhesion forces, but look at the lower meniscus. And you also have to look at the scale. This is a 2, 4, 6 kind of scale. So every division here represents a 2. So every division represents a 2, meaning that this is actually a 6, 6.2, 6.4 is our answer here. 6.4 because of the nature of the scale. Okay, every division represents a 2. So our answer here is a B. Okay, our answer there is a B. Next question, the best and suitable method of collecting pure water from a solution of ink is? My answer was distillation. You're talking about collecting pure water. Distillation will separate the water from the ink. Okay, ink usually is non-volatile. It doesn't evaporate. If you say chromatography, it won't really be the best. It's one way of separating, but it's not the best, and they're asking for the best. Distillation would simply be the most effective way of obtaining water from a solution of water and ink. 24. Which of the following is true about isotopes? You have to know what isotopes are. Atoms having the same atomic numbers but different neutron numbers, meaning that they will have different mass numbers, but the number of protons will be the same. So which of the following is true about isotopes? A, 2 or more elements belonging to the same group. No, group, that's too broad. B, they have the same chemical properties. Yes, they have the same chemical properties because they have the same number of protons, meaning that they will have the same number of electrons, meaning that they will have the same valencies, meaning that they'll behave the same way chemically, but they'll differ physically. Our answer is B. 25. Which of the following sets contain particles with the same number of electrons? I had to write this down because you can't easily tell by looking. You have to somehow count. And so when they say sodium ion, you have to know what sodium ion, how a sodium ion looks like and its configuration. Oxide ion, this is our oxide ion up here. So when you count the number of electrons, all of them is 10, 10, 10, and they're asking for the set of species with the same number of electrons. My answer is B. Okay, answer is B. Use your periodic table and physically count. 26. Limestone, which is calcium carbonate, decomposes to lime, which is calcium oxide or baked lime, according to the equation. Our equation is right here. Okay, decomposition reaction. What mass of limestone would produce 11.2 grams of lime? This is theoretical yield. You have to use your given equation to determine the amount of limestone that would produce 11.2 grams of lime. So from the equation, the mass number of this is 100. This is my 100 here. Okay, calcium is 40 plus 12 plus this is 16 times 3, which is about 48, if my memory is right. So 48 plus 12 plus 40 should be able to give you 100. And then the mass of calcium or limestone there is 56. calcium oxide is 56. So from my equation, 100 grams yields 56 grams of limestone using theoretical ratios. These are the theoretical ratios. Therefore, x grams, they're looking for the mass of limestone. What mass of limestone would yield 11.2 grams of lime, which is this substance here. So I'll use my balanced equation. This equation is already balanced the way it is. So I'll use, this is 100 mass, the molar mass here. Not really molar mass, but the mass in the equation is 100 and the mass here is 56. So from our balanced equation, our balanced ratios, theoretical ratios, 100 yields 56. Therefore, x should yield 11.2. Then I cross multiply. When I do my cross multiplication ratios here, it's giving me, or when I work out this, I cross multiply this part here, I'm going to have something like this, where I'm going to have 56 times x, that is my 56x here, or x56, but then I'm supposed to write it as 56x. Then this is going to be, when you cross multiply like that, this is going to be 100 times 11.2, which is this part here on top here. Then I divide by 56 on both sides, or to simply make x my subject. So in our, or on our answers, it's not complete, meaning they have left it hanging. So even here, this will be the expression that they're looking for. Therefore, answer comes out as 100 times 11.2 over 56. Then you've got your grams at the end there. Our answer is A. 27 below is the chemical equation. Okay, that's our chemical equation. What are the correct values of A, B, C, and D? Therefore, this chemical equation is balanced, but they want you to identify the coefficients in that chemical reaction. So this is actually, it looks like ethene, okay? Ethene burning in oxygen to yield carbon dioxide and water. Carbon dioxide and water. This is actually not really ethene, but ethane, because you're having 4 plus 2, 2n, that is 4 plus 2 gives you 6. So it's actually ethane burning in oxygen to give you carbon dioxide and water. Hopefully I'm correct when I say ethane. The thing is, I balanced my equation to give me this. When I balance, I first of all balance my hydrogen to make them 6, just like 6 here. Then I balance my carbon to make it 2, just like 2 here. But I realized for me to balance the oxygen last, because it's alone, it's easier to balance the one that remains alone. I realize I have a decimal, and we don't really get to value decimals because this would mean 3.5 atoms or molecules. It's like you're having half a molecule. And so ratios here decimals cannot really work out here. Fractions are not welcome here. So you have to have whole numbers. So I balanced it, then I realized in my balancing I had the decimal here. So this 3.5 will give me 7. Even on the other side, I'm having 3, which is this one, then this is 4. Okay, so 4 plus 3 gives me 7. Even this one, 3.5 times 2 is 7. It's correct, but I need to have whole numbers. Whole numbers are what we work with to avoid confusion and to simply respect logic. So I simply multiplied my equation by 2. Okay, I chose the number 2. I kept it as small as it could be. So I multiplied by 2, and it gave me 2 times this ratio, this species here gives me 2. 2 times 3.5 gives me 7. 2 times 2 here gives me a 4. 2 times the 3 over there gives me a 6. So my answer comes out as 2746. 2746. Okay, so you balance. Where you have decimals, make sure you convert those decimals to whole numbers by multiplying by the simplest whole number. That will simply give you the lowest whole number ratios of the species in the equation. Our answer there is A. 28. Which of the following is true about an exothermic reaction? What? I didn't even solve this one. But you and me know to say exo means outside or outward. Thermic is simply related to thermal energy, a reaction that releases thermal energy to the environment. So our answer here would be temperature of the surrounding decreases. No, if it decreases, it means the reaction is taking in, it's absorbing heat. That's why the temperature in the surrounding is decreasing. B, the enthalpy change is positive. No, not really. Usually exothermic reactions have got negative enthalpy changes. Bonds formed are relatively stronger than bonds broken. Okay, if energy is being lost, it means the resulting substances are going to be much more stable. They will have a lower internal energy. Therefore, of course, their bonds will be stronger. Yes, it's like you're having from petrol. You burn petrol to have carbon dioxide then water. The two compounds are much more stable than the petrol. Petrol has got higher potential energy. Let's look at D. Heat is absorbed from the surroundings. No, D is just the same as A. So my answer there is C. Bonds formed are relatively stronger than bonds broken, meaning that the stronger aspect means stability. Okay, in an exothermic reactions, the products become more stable because they have excess energy has been released from the previous compounds. I don't know how I can explain this, but I hope you're seeing what I'm trying to say here. So my answer there is C. Next question, silver oxide and hydrogen peroxide react as follows. Therefore, you've got our silver oxide, hydrogen peroxide, then you've got silver metal, water, and oxygen gas. In the reaction, hydrogen peroxide acts as a reducing agent. Reduction is the loss of oxygen. Oxidation is the gain of oxygen. Apart from that, when you look at silver in this equation here, it is actually an ion. This is an ionic compound. Silver has a charge of +1. There's a valency of 1. But it has a charge of 0 because it's neutral. So from +1 to 0, that's a reduction. From +1 to 0, like on the number line, meaning silver has been reduced. Therefore, the hydrogen peroxide is the reducing agent. It reduces silver from +1 to 0. From the other point of view, it simply removes oxygen from silver, meaning it is still reduced because that is still reduction. Our answer there is C. Number 30. Which of the following salts can be crystallized from an aqueous solution? Meaning this salt is soluble. If you're talking about crystallization, it means salt is soluble. So when you look at all these salts here, barium sulfate insoluble, lead-2 sulfate insoluble, silver chloride insoluble, meaning these three can be prepared by precipitation. You don't need crystallization. But all sorts of ammonia are soluble. All sorts of potassium, let me just write it here. All sorts of potassium, all sorts of sodium, all sorts of ammonium are soluble salts. Okay, so remember that. So ammonium sulfate would be the salt that would be prepared by crystallization from an aqueous solution. Our answer there is D. 31. Solution R forms a white precipitate with little amount of aqueous ammonia. The precipitate dissolves in excess aqueous ammonia to form a colorless solution. Which cation is present in R? I had to check this from my notes. Yeah, I should also check, but the thing is my answer there is D. They've said it forms a white. Okay, so the keyword there is a color, and also what happens when you add little ammonia and excess ammonia. But the answer there is D. You have to read your qualitative analysis notes, and you find the information about these. They usually confuse me, but hey, I got this one right. I know that. 32. Thermostability of a metal nitrate depends on the reactivity of the metal. That's true. That's correct. Which of the following represents the change when potassium nitrate is heated? My answer there is B. You have to have seen these equations before. Okay, thermostability of hydroxides, thermostability of carbonates, thermostability of nitrates. Okay, so our answer there is B. I didn't just guess this one. I also had to check it out from somewhere. So you also have to check it out from your notes or from a topic of metals. Our answer there is B. 33. Which of the following is true about chlorine, bromine, and iodine? My doc used to say bromine, but it sounds nice, but I think it's bromine, doc. It's bromine. That's Dr. Prakash. So which of the following is true about chlorine, bromine, and iodine? They all have colors. That's very true. 34. When hydrogen is fitted into a reactivity series of metals, it comes immediately after lead. Before copper, but after lead. So our answer there is C. Even for this one, you should have seen the reactivity series. So our answer there is C. The more you read your work, the more you get to be familiar with such. When you just say after lead, it means I've seen it before, because it's an arrangement. So you have to have seen it before to remember where the hydrogen comes in. Okay, yeah. Next question, 35. Which of the following is used in the manufacture of margarine? That's hydrogen, usually in the process of in the presence of the catalyst nickel, if my memory serves me well, and temperatures of about maybe 300 degrees Celsius, nickel as the catalyst. You hydrogenate vegetable oil to its saturated form that you'd call margarine, hydrogen. 36. Three similar test tubes containing the gases KLM are inserted as shown in the figure below. Cold water, KLM. Yeah, when you look at M, the water has gone up all the way. L, the water has gone up halfway, I would say. Then K, nothing has happened, like the water has remained down there. The gases KL and M could be, so here you also have to have read, like you really have to go through your work, the concepts and topics, for you to just make certain conclusions, like the way I found this answer. Understand that ammonia is highly soluble in water. So if you put ammonia in a test tube, it will dissolve in water. So the water will simply climb up. The water will be more like sucked up. So M is ammonia. Carbon dioxide is the second one, meaning carbon dioxide is L. Carbonated drinks, carbon dioxide is quite, moderately soluble in water. But carbon monoxide, no. So K is monoxide, L is dioxide, M is ammonia. Our answer there is A. 37. A sample of air of volume 200 cubic centimeters is enclosed in a tube containing moist ion fillings. After the ion has stopped rusting, what volume of air would be remaining? Can't believe I didn't calculate this one. But you have to understand that in every natural sample of air, about 20, some books will say 21, okay, about 20% of the air is going to be oxygen. So you simply have to find the 20% of this, then subtract it from the 200. How do you do that? You simply say 20 is 20%. Percent means per 100. So 20 per 100, meaning 20 over 100 times 200. The answer you find here, subtract from the 200 that you've been given up there, then your answer should come out as 160. Okay, I'm not so sure if I had used 21 or 20, but some books use 21, some books use 20, but that's how you find it. So understand the composition of air, natural composition of air, percentage composition of air. Our answer there is C. 38. Cyclobutane has the structure as shown below. Which of the following is true about cyclobutane? It is a cyclone. Yeah. My answer there, it is a saturated hydrocarbon. That's very correct. A, it is an alkene. No, it's not an alkene because it is saturated. There are no double bonds in there. C, its empirical formula is the same as that of all alkanes. No. D, it decolorizes. No. Our answer is B. Question 39. What is the reaction product when ethene is treated with steam using phosphoric acid as catalyst at 300 degrees Celsius? The product is going to be ethanol. Okay, it's going to be ethanol. Take it out from your organic chemistry. Number 40, which is our last question there. A compound P has the molecular structure as shown below. I can tell that's a dicarboxylic acid, but at the same time it's actually unsaturated because of the double bond between the carbon atoms here. Unsaturated with two carboxylic acid groups. How can P be described? Okay, carboxylic groups. How can P be described? B, my answer was B, both an alkene and an acid. I think that was my best answer. You cannot say alkane like in A here. You cannot say alkane here. You cannot say alcohol. No, this is a carboxylic group. Carboxylic group, double bond. My best answer there is B. This is the end of this paper. I'll see you in more papers. I'll try to make as many as I can. If it means millions, I'll do that. And you realize that ECZ has run out of ways of asking questions. You see a pattern. You're going to see that it's the same old thing. Same old guy in a different green suit. Okay? So I'll see you in the next video. But for now, I'll say bye-bye. And remember to subscribe and share these videos with friends and see what you can correct and simply do more, and use them as reference and all that. From me to you, I say bye bye for now. Cheers.